Hello everyone. In this tutorial, we are going to provide a solution to this interesting sequence problem. Don't forget to like, comment, and share to your learning colleagues. Let's get started. We're asked to find the 10th term of the sequence, and you can see the sequence here. We have 5 terms. Always, to determine a particular term, it is important to recognize the sequence. Which type of sequence is this? Then secondly, come up with an expression that defines every single term, which is nth term. All right. In my own case, I would like to test for geometric sequence first. In geometric sequence, we have a constant common ratio called R. This R is used to multiply every single term to get the subsequent term. So the question is there any number we can multiply by 4 to get 13? So that such number will be multiplied by 13 to get 40, that number times 40 to get 97, and that number times 97 to get 196. We don't have such number. All right, since we don't have such number, now let us test for arithmetics. In arithmetic sequence, we are going to find one number which is called a constant common difference, which we have to add to 4 to get 13. The same number will be added to 13 to get 40, and so on. If we could not get that number, then we test for quadratic sequence by taking the second difference. If in the second difference we could not get a constant common difference, then we go to the third difference in that order. All right, so let's get started. We have 4 right here, we have 13 here, we have 40, we have 97, and we have 196. We call this what? Terms. So I think it is important to give them a number. So let me drop it down here. You should know that this is term number 1, this is term number 2, this is term number 3, we have term number 4, and term number 5. All right. This is when n is equal to 1, 2, 3. This is use of n. That is the terms we have. Then I would like to take the first difference. First difference. What is going to be the first difference? What number can we add to 4 in order to get 13? We can add 9 to 4 to get 13, right? So you add 9 here. What number can be added to 13 to get 40? 27, right? So we have 27 right here. What number can be added to 40 to get 97? The number is 57, so we have 57 right here. What number can be added to 97 to get to 196? And the number is 99. And you can see that all these numbers are not the same. They are entirely different. Then you move to the second difference. Now the second difference. Had it been we got a constant common difference here, then we can finalize that this is a linear sequence. Now let's move to the second difference. The question is, which number can be added to 9 to get 27? We can add 18, right? So if you add 18, you're going to get 27. Then from 27 to 57 is by addition of 30. Yes. And from 57 to 99, you can simply add 42. And these 3 numbers are entirely different, which means that this sequence here is not quadratic. If it is not quadratic, we move on to third difference. The third difference. From 18 to 30, what do we need to add? We need to add 12. And from 30 to 42, we need to add 12 as well. So now we have a constant difference. Since now we have the constant difference in the third difference, it implies that this sequence is what? Cubic. And how do we express it? Un must be in the form of an to the third power plus bn to the second power plus cn plus d. This is the general form where we have to find a, b, c, and d. All right. So since this is the general form, Now we are going to form another table similar to this one, but using this expression. Let's get started. What happens if n is equal to 1? Because that's what is going to give us the first term. When n is 1, you can see this is going to be 1, 1, 1. So we only have a plus b plus c plus d. That is our first term. The first term is a plus b plus c plus d. Now, what will be the second term? The second term will be when n is equal to 2. When n is equal to 2, you can see this is going to give us 8. So let me write it here. We have 8a. This is going to be 2 to the power of 2, which is 4. So we have 4b plus, this is 2 times c is 2c, then plus d. Now the next one, when n is equal to 3, we have 3 times 3 times 3, which is 27. Right? We have 27a plus 3 times 3 is 9. We have 9b, 3c plus d. I think I need to add one more, so let me bring them closer to each other. So lastly, I would like to take when n is equal to 4. Already we have 3 times. When n is equal to 4, we have 4 times 4 times 4 times 4, which is 64. 64a plus 4 times 4 is 16b, 16b plus 4c plus d. All right. The same thing, we have taken first, second, and third difference. We are going to do the same thing here. What will be the first difference? To find the first difference from here to here, all you have to do is to take this and subtract this. 8 minus a will give us 7a. 4b minus b will give us 3b. 2c minus c will give us c. D minus d is 0. Then we move to the next one. 27 minus 8 will give us 19, right? So 19a. Then 9 minus 4 will give us 5b. 3c minus 2c will give us c. D minus d is 0. Then we move to the last one. 64 minus 27 is 37, right? 37a. 16b minus 9b is 7b. 4c minus 3c is c. D minus d is 0. This is our first difference. Then we move to the second difference. From here to here, we need to add what? 19 minus 7 is 12, so we have 12a. 5b minus 3b will give us what? 2b. Now from here you move to this. 37 minus 19 will give us 18, right? 18a. 7b minus 5b is 2b. C minus c is 0. Then the third difference. Remember we got third difference previously. From this to this. 18 minus 12 will be what? 6, right? 6a. 2b minus 2b is 0. So in the third difference, this is going to be constant all through. 6a will be constant difference. And we are going to relate this constant difference with this constant difference. So this is like a back substitution. 6a must be equal to 12, right? Divide both sides by 6. A definitely equal to 2. Now we have the value of a. Now we need to find the value of b. I'm going to take this expression here and relate it to which expression? To 18. Second difference, first term. This is our second difference and this is our first term. 12a plus 2b must be equal to that number which is 18. But remember, a is what? 2. So we have 12 multiplied by 2 plus 2b equal to 18. This is 24 plus 2b equal to 18. You can even divide both sides by 2. so that this becomes 12, this becomes B, this becomes 9. And B will be equal to 9 minus 12. And what is 9 minus 12? Minus 3. So B is minus 3. Now let us go ahead and find C using the first difference, right? This is the first difference, first term. Let me write it first. 7A plus 3B plus C. Now I need the first difference, first term, which is 9. This is equal to 9. But remember, A is equal to 2, so we have 7 times 2 plus 3 times what? Negative 3. Remember, B is negative 3. Then plus C. This is equal to 9. This is 14 minus 9 plus C equal to 9. 14 minus 9 is 5, and you can take that 5 to the other side. It becomes negative, so C is equal to 9 minus 5, which is equal to 4, right? C is equal to 4. Now the only term we need to find is D, and that can be obtained from the first term. Remember, this is our first term, which must correspond to the first term here, which is 4. So A plus B plus C plus D must be equal to 4. A plus B plus C plus D equal to 4. A is 2, B is minus 3, C is 4, D is what we are looking for. Everything equal to 4. 2 minus 3 is minus 1. Minus 1 plus 4 is 3. Then you take that 3 to the other side. You have D equal to 4 minus 3. And D is equal to 1. Now we have A, B, C, and D. Remember our expression, UN is equal to AN to the third power plus BN squared plus CN plus D, right? So what is A? A is 2, remember. A is 2. So use of N is equal to 2N to the third power. B is minus 3, so we have minus 3N squared. What is C? C is 4 plus 4N, and D is 1. Yes, so this is the N term of that sequence. But remember, we are looking for what? The 10th term. So to find the 10th term, all we have to do is to replace N with 10. Use of 10 is equal to 2 times 10 to the power of 3 minus 3 times 10 squared plus 4 times 10 plus 1. This is what we need to simplify to get the 10th term. 2 to the power of 3 is 1,000, and 1,000 times 2, this is 2,000. Minus 10 to the power of 2 is 100, and 100 times 3 is 300. 4 times 10 is 40. And lastly, plus 1. Now you take 2,000, you subtract 300, that will give us exactly 1,700. Then you add 40, that will give us 1,740. Then you add 1, you get 1,741. Yay! This is the 10th term of that sequence. As simple as that. Thank you for watching. Do share to your learning colleagues. Bye-bye.